Alright, so let's go ahead and start with some local variables. So we're going to continue working on our current run view controller, and I'm going to create some, first of all, a mark, local variables. So as you can see, when I type cl location, it's not coming up because we haven't imported from core location. So let's go ahead and import from core location. And there we go. So we're gonna keep it forced unwrapped, and we are going to populate this before using it, so it's not gonna be crash. But yeah, this gives us an opportunity to basically keep the label instance. So we're gonna keep the run distance. This is just gonna be another local variable, and there's gonna be time elapsed. And a variable to keep the pace. Okay, we also gonna initialize our location manager, and a timer. All right, so now for the view life cycles, the first thing we're gonna do is, once again, we're gonna set up our views, function for that, and set up constraints. Right, so now we're gonna be able to add our views and basically our constraints. Okay, so that's for setting up our view. But on view did load, or we did appear actually, what we want to do is, first thing we want to call view did appear for the superclass, and we're also gonna call the location manager and get the manager and assign ourselves as the delegate, and we're gonna create a function called start running. Okay, all right, let's go ahead and create our extension. So current run view controller extension, and we wanna extend CL location manager delegate because we wanna keep track of, like, where user is running, so we can actually track their location. Okay, so that's what we're gonna do with the delegate. On the view did, we will disappear, we want to stop the run, so view will disappear. We're gonna call stop run, and we are also gonna call super dot view will disappear animated. Okay, so it's gonna be another function. There we go. Okay, so now for the start running function, what we want to do is we want to call our location manager, and we're gonna call start updating location, not the heading but the location. So this is gonna start sending events whenever user would start running. And we also want to basically update our labels for pace and, like, time and stuff like that. So we're going to call a function called start timer, and this timer function is going to keep basically the timer, and going to be responsible for updating um, those um, labels, right? Um, and when you stop running, we're going to call location manager dot stop updating location. Okay, and we want to call stop timer here because we do want to reset our stop the timer and reset it. So we're gonna call our creative function stop timer, like so. All right. So now when we have, like, our start timer and stop timer, let's go ahead and put some code into that too. So our time label text is going to host the time that has been elapsed. So time elapsed has int value. Now we do want to format that into a time string. Okay, so the way we can do that is we can create a new file, and we're going to create an extension on the int. Okay, and so we're going to call this int plus extensions. Okay, and this basically what it's going to do is it's going to receive the integer time elapsed, and which is going to be in seconds, and we're going to convert that into a time string. Okay, so we're going to simply say extension for int. Okay, and we're going to call format. The function is going to call format time string, and this is going to return a string. Okay, so we're going to first compute hours in the time. So we're going to say self divided by 3600, which is 60 times 60. So 3600 to get the hours, number of hours so far in time lapsed. Then we're going to have minutes. So minutes we can get by self dividing or modding that with 3600. Whatever the remainder is, divide by 60 will get us the minutes. Okay, and then you have seconds, which is once again self mod 3600, and we're gonna mod this by 60, and this is gonna give us remaining time, which is gonna be seconds. So if seconds is less than 0, so in that case we're gonna simply return 0. Otherwise we're gonna say if hours is equal 0. So in that case we don't want to show the hours label, so we're gonna simply return string format, and this is how you format the string. So you can pass basically the format string, which is going to be %0 to d. Okay, and colon, that's what we want to basically separate our time with, and %0 to d, another one. And this is going to take get the minutes and seconds. So essentially what this is going to print is if it's 12 minutes 25 seconds, this is going to be printed as this format. Okay, now in case of else, we're gonna return a string with format, and this time we're gonna have 3 of these. So %0 to %0 to d colon %0 to d colon %0 to d, and this is going to be, first one is going to be for hour, second is going to be for minutes, and third one is going to be for seconds. All right, now going back into our file, we're gonna simply call this format time string, and this is going to format our time elapsed into the time format. Okay, so that is your start timer. First thing you're gonna do that, and then so this is gonna basically if the time has if the time elapsed is just initialized with 0, then the format is gonna be 0000. Okay, and then we're gonna set our timer or reinitialize our timer with timer dot schedule timer with time interval. Okay, and time interval is going to be every second. We're going to target set the target for ourselves. There's going to be a selector which we're going to call this update timer. Okay, user info is going to be nil, and we're going to keep repeating this timer every second. Okay, now about this function, we're gonna just create that at obj private func like that. Okay, so this is gonna be your start timer, right, which is gonna basically set the label with 0 zeros, initialize the timer. For the stop timer, what we want to do is timer dot invalidate first. Okay, and set the time elapsed to be 0. All right, and this function, the timer schedule timer, is gonna basically take the responsibility to start, like, running the timer. So then we wanna update our time lapsed every second with 1. So we're gonna keep adding 1 into that, and we're gonna update the time label dot text is equal to time elapsed dot format time string. Okay, all right, we need one more function, and this function is gonna basically compute our pace. Okay, so let's see. All right, so compute pace, what this is gonna do essentially is it's gonna take the time in seconds and miles that we have tracked so far, which we're gonna do inside the extension, and it's gonna basically compute the pace at which user is running. Okay, so we're gonna create this function and we're gonna use this very soon. So compute pace for time in seconds, which is going to be int, and miles, which is going to be in doubles, and this is going to return us a string, and we're going to simply say pace is equal to int value. We're going to get the double from seconds, and we're going to divide that by miles. Okay, and that's how we're gonna get our pace, and we're gonna return pace dot format time string. Okay, so those are all of our helper functions. Now let's go ahead and set up our view. So we're gonna first add sub view for top label. We're gonna add sub view for page stack view, and add sub view for capsule view. Now capsule view dot add sub view stop slider knob. Capsule view dot add sub view slider stop. Okay, all right. Now for the swipe gesture, now this slider needs a swipe gesture basically, and we're gonna use the UI pen gesture recognizer, and we're gonna attach that to the slider knob. Once again, going back to the app, this guy right here is the pen gesture that we are applying in X direction, and that's what we need. Basically, we need this to be applied. So what we're going to do is we're gonna simply create it inside the setup view. So let swipe gesture is equal to UI pen gesture recognizer. Target is going to be self, and the selector is going to dismiss the view controller. So we're gonna say dismiss and we're gonna have a sender here. Okay, and gonna create that function. Dismiss end. It's gonna have a sender UI pen gesture recognizer. Okay, and then we're gonna attach this swipe gesture to our stop slider knob. So add gesture recognizer, swipe gesture, like so. All right, so that is our view that is set up. Now for the constraints, what we're gonna do is we're gonna set up our top label first. So we're gonna set it to leading, trailing, top, and height. So leading, trailing, top anchor is going to be constrained to view dot safe area layout guide dot top anchor, and for the height we're gonna say equal to constant, and we're gonna put that constant of 50 as a height. Okay, now next thing we wanna set is page stack view. So page stack view, once again this is the stack view that contains all of our labels, so we're gonna simply say ns layout constraints dot activate, and we're gonna set page stack view dot leading anchor dot constraint equal to view dot leading anchor. Trailing anchor is going to be constrained to view dot trailing anchor. And for the top anchor, we're going to constrain this to top label dot bottom anchor with the constant 8. Okay, now for the other constraint, we're gonna define that inside our capsule view, because we want to create a relationship between our page stack view and basically a constrained relationship between our page stack view and capsule view. So let's use the capsule view layout constraint dot activate, and we're gonna say capsule view dot width anchor is gonna be constrained to $300. Okay, and height is gonna be constrained to 70, and then bottom anchor is gonna be constrained to view dot safe area layout guide dot bottom anchor. Okay, and capsule views top anchor is going to be constrained to page stack view dot bottom anchor with constant 8. Okay, so this is basically going to create that that constraint relationship between the capsule view and the page view. And one last, we want to have our capsule view to center in X direction, so we're going to constrain that equal to view dot center X anchor. Okay, now these are all of our main views. Now how about our stop button inside the capsule view and slider stop knob? Okay, so let's go ahead and create constraints for those. So stop button slider stop button or knob. Basically this is just a location because we are gonna create basically we gonna, whenever the slider pen gesture happens, we wanna check if these the the sliding knob is essentially so whenever the pen gesture happens, we're gonna check if the sliding knob's center has collided with the center of the stop button, right? And that's how we're gonna detect and dismiss. Okay, so so that's what we're gonna actually sort of like plan for. This is not essentially not exactly a button, so that's why I didn't I kept calling button, but it's not. Okay, so it's a stop slider knob. Sorry, stop slider knob is the slider that you're sliding, is this guy right here. Okay, the one that you're sliding. So we're gonna have that. All right. So stop slider knob leading anchor is gonna be constrained to capsule view dot leading anchor with constant 8, and stop slider knob dot center y is going to be constrained to capsule view dot center y. Okay, and then its width anchor is going to be constrained to 50, and height constraint is going to be constrained to 50 as well. Okay, so we're gonna make it a circle. All right, so that is the slider knob, this guy. Okay, now we need this button right here. Okay, so this is like slider stop circle or image. Okay, and it's layout constraint dot activate, and you're gonna call this slider stop dot trailing anchor dot constraint equal to capsule view dot trailing anchor. Okay, slider stop dot center y constraint equal to capsule view dot center y, and slider stop dot width anchor dot constraint is equal to constant, and this is going to be 70. I'm gonna copy this and paste it, and I'm gonna change this to height. And if you notice, this one, this stop button is slightly bigger than the slider button itself. That's why we are actually creating it as 70. Okay, now there are just a couple more things left, so let's go ahead and finish those. So first of all, the dismiss and. Okay, so this guy is when we are actually gonna recognize that gesture that the slider has passed or collided with the center of the stop button. So let's first create an adjust variable. So it's gonna be of CG float, and we're gonna have 35 as a computed value, which is half of 70. Okay, and we're gonna use that inside our computation. Then we're gonna have translation, which is gonna be sender dot translation in view. So how much it has translated, like since the pen gesture has started, like whatever the value that your pen gesture is sending for the translation itself. Now we're gonna detect the state for the sender. If the pan or swipe gesture has began, or sender dot state is in change. Okay, so if the slider has begun sliding or it has changed, that means it's continuously sliding, then go in this if block. Otherwise, if sender dot state is ended and stop slider knob dot center dot x is less than slider stop dot center dot x. So basically you have stopped somewhere in the middle, and your two centers are not colliding. Essentially what we want to do is we want to bring this button back to the initial position. So what we're going to do is we're going to simply say UI view dot animate with duration, and duration is going to be 0.5, and the animation itself is going to be self dot stop slider knob dot center dot x is equal to self dot capsule view dot bounds dot min x plus adjust. Okay, so it's going to bring it back to the initial value with 35 points, like shifted 35 points for the center. Okay, so that is when user leaves the knob in the middle. But what if they have begun and it's going, it's sliding? Then we want to do few checks in that case as well. All right, so the way we're gonna do that is first we're gonna put a like if statement. If the stop slider knob dot center dot x is greater than slider stop dot center dot x, okay, or we can actually say it's greater than equal to, okay. If that is the case, that means this is the state where collision has happened. So we're gonna say stop slider dot center dot x is equal to slider stop dot center dot x. So we want to just basically align their centers, so it's right behind, and we're going to call stop running or stop run. We also want to dismiss our view in this case, and we're gonna dismiss it with animation as true. Okay, now that is the first case. Now what if the center, the stop slider knob dot center dot x is less than the capsule view dot bounds dot min x plus adjust? Okay, if that means if the slider has gone, basically slider is trying to slide beyond these limits for the capsule, then we want to actually bring our slider back. So we're gonna say stop slider knob dot center dot x is equal to capsule view dot bounds dot min x plus adjust, because we and I just realized I've actually misspelled this, so rename. There you go. Okay, so we're gonna adjust that, right? We're gonna actually bring it back. And last case, if none of this is basically none of the conditions are true, then we want to take our stop slider knob dot center dot x and add translation dot x to that, so we can actually reflect that inside our knobs translation. Okay, all right, now let's do the last thing, and this one is basically getting the updated location. So did update location is a function that is called whenever the new location update is available, and we want to say if the start location is nil, that means our run has just started, right? Then we want to say start location is equal to location dot first. All right, so we're gonna initialize that. Else if we're gonna first get the location from locations dot last, and locations is coming from here, basically the locations that have been tracked by core location, and they are actually giving it to us. We want to say run distance is equal to, or run distance plus equal end location dot distance from the location that we have extracted from the last location. Okay, and then we're going to say self dot distance label dot text is equal to self dot run distance. Now the distance actually comes in meters, but we need to convert it into miles, and then we need to convert it into a string with 2 places of decimal. All right, so best way to do that is create another helper, and we're gonna call this one double plus extensions. Okay, and this is basically going to include the extension on double, and there are going to be 2 functions. First function is going to be meter to miles, which is going to return a double value. All right, and there's going to be a function to string places, and we're gonna see, like, how many decimal places we want, and we're gonna return the string. Now the way we're gonna return, we're gonna actually create a string with format, and we're gonna say percent dot and places that's been passed into us for self, and this is going to be f here, okay, for decimal values. And here the meters to mile is simply you're gonna say meters is equal to, we're gonna use the measurement, and we're gonna supply the value self, and basically tell the unit length is going to be meters. So currently so we're gonna actually take that double value, convert it into a measurement of type meters, because we know that value is coming from in meters, and we're gonna return meters dot converted to miles. Okay, and we're gonna take out its value and return that, and that value is going to be double. So that's how we don't have to worry about, like, the computation. Let the measurement framework figure out how to compute the miles for us. Now going back into our update location, the run distance is gonna have meters to miles, and we're gonna call that, and to string is gonna be, we need this value up to 2 places. Okay, now we want to say if the time elapsed is greater than 0, right, and the run distance is greater than 0, if these 2 values are 0, then we also want to update the pace label to the computed value. Remember this compute pace function that we created? We can actually call that, we're going to pass our time elapsed into that, run distance dot meter to mile as well. Okay, and one thing that we want to make sure that we do is we also want to populate our end location with locations dot last. All right, so that is all there is basically for our current run. Now when we go, like, into our home view, we want to make sure, like, that we are calling this current run somewhere. Okay, so let's go to our home view, and at this point we are not calling, so whenever we click on the start button, start running, we simply say, like, print. So if you want to change that, we're going to create let current VC current run VC is equal to current run view controller, and We want to say current run view controller dot modal presentation style to be full screen. So we don't want it to be dismissible modal. And like, then we're gonna just present current VC animated true, no completion. All right, let's go ahead and launch this. And what we should see is basically our user is still running, and we want to click on this run button, and then we have our labels, and as you can see our labels are updating. And let's check out this guy. So as you can see, there is as soon as I touch, there is like automatic slider that's going in. Okay, so let's take a look. What is the issue on the sliding? All right, so for the slider, we have the translation going in the view. If the state has begun or changed, we want to say, oh, so let's see if that actually helps. No, it did not. Okay, so slider knob dot center is equal to slider dot stop, but there's a pan gesture, so we want to say if the slider stop dot center dot x dot min x. All right, so it looks like this line. Oh, okay. So there's one thing that we actually forgot is we forgot the translation. So sender dot set translation. Basically, this sets the translation value to the coordinate system, right? So this is where we need to set it to 0, so it can actually continue to update. Okay, so let me go ahead and update that. And if you notice now, because these set translation is now local, now it's not actually just sliding away until we actually reach to the end, and when the actual centers collide. And as you can see, our pace is increasing, our distance is also increasing, so our labels are updating just fine. All right, so this is our this was our current run, and next we can actually work on our logs page, okay, which is gonna just have a table view for this, and then we're gonna introduce realm. And once we introduce the realm, then we're gonna start using realm database. Whenever we are dismissing the run, we are actually going to store it in realm, and this logs page is going to pull that information from the realm itself. But in order to create the view, we're just going to create that in next video and get the view ready and set up, and then we're going to introduce realm part.